Hi there. In today's episode, we'll be discussing the state of the art in computers understanding and speaking to us through something called natural language processing. Welcome to the Productive AI podcast, where we aim to simplify AI and make it more accessible to business leaders. I'm your host, Troy Angrignon. If you're interested in how computers can be used to read, write, translate, and speak language, you're going to want to listen to today's episode with Scott Leishman from XOKind. He's got an extensive background in the space, and I think this is going to be a really interesting conversation. Also, if you stick around to the end, I will be asking Scott for his thoughts on additional resources and what to do if you're interested in working in this field, since he's kind of so embedded in it. So with that, I will hand it over and say, Scott, thanks for coming on the show today.
Hey, Troy. Thanks for having me. Great to be here.
So maybe what would be really great to start is if you could just kind of walk us through kind of your background, where you came from and how you ended up here, because you're currently working in a startup in the natural language processing space. You don't just fall into that. That's not something you do straight out of school, generally speaking. So I'd love to hear kind of your background and what brought you to this point.
Sure. Yeah. I've had a pretty broad background, not to date myself, but I've been in the field for a little while now. It goes back to I got a first interest in sort of machine learning and AI back in sort of my undergraduate days. I was at the University of Toronto in 2003. Managed to kind of do a summer project with the person who ended up being my supervisor, who was part of the machine learning group there. So I spent 2005 to 2007 doing my master's. One of my grad school colleagues ended up getting a job in San Diego. So that's how I ended up moving from Canada, where I was born and raised, to California, where I've kind of been ever since. So it was kind of interesting to be part of that group at the time, because there's been a lot of luminaries there. It was sort of the ground zero, if you will, for deep learning, which is obviously very prominent and very popular today. I got the opportunity to learn from some luminaries and visionaries in the field. But my kind of first job out of school was applying models to predict credit card fraud. So I worked for a company called FICO, who you may know from your credit scoring days or various aspects like that. So at that time, deep learning hadn't yet taken off. My role was kind of a statistical analyst would have been the title then. This sort of predates data science or that title, but doing a lot of the same kind of tasks. So that's what got me into sort of industrial level machine learning, where I've kind of been ever since. And throughout my career, and as I've progressed through different companies, I've gotten more of a kick out of the software side of that. So not just kind of training these models, but taking them and scaling them and making them work and work well in a real world setting, which is very different than when you come out of academia or you see these little tutorials online. So I spent a couple of years at FICO, and then spent about 4 years after that, kind of doing a similar thing, but in the mortgage space. So I worked for a company called CoreLogic, where one, we had a lot of data. Like, we'd go off to all the different processors in every single county in the US and would build models to predict things like mortgage fraud, both sort of like white collar fraud, organized crime, as well as people doing things like trying to fudge their reported income to get a better rate. I also worked on things like mortgage-backed security analysis and risk analysis, and putting models and associated software in place to support that. And then in 2014, I kind of stumbled into it. From my old grad school days, I was part of a mailing list where a company in San Diego was starting up a deep learning startup, which kind of caught my eye, seeing that San Diego has a pretty, they've been around for a while in terms of like analytics and machine learning, but it hasn't been as prominent as, say, like the Bay Area or some of these other kind of hotspots. So to kind of see that in my hometown, or sort of newly adopted hometown, was pretty exciting. So I kind of had to find out more. Ended up talking to the founders, and was an early employee for a company called Nirvana Systems, which was focused in the deep learning space, but was looking at producing custom hardware. So if you followed the space, you'll see that it's, building these models is very compute intensive, resource intensive, and people are using GPUs today. You're starting to now see the kind of emergence of this custom silicon, dedicated chips that are tailored specifically to training deep neural networks at a kind of faster pace. So that caught my eye, because right around the time too, I was interested in Bitcoin, and I saw the same kind of progression happen there, right? You used to be able to do mining on your local laptop, maybe you needed a GPU, and then people started selling ASICs, and that became the dominant way to do that. So I was really excited by the idea, and ended up being, I think, employee number 5 or 6 there, and did a lot of work on the software side of that. So we thought about kind of selling this hardware. You need the kind of full software stack to go along with it. So my initial role there was working on the deep learning framework. It's called Neon. We open sourced it. It predated TensorFlow, but if you're familiar with that, it's kind of the equivalent sort of piece of software in the stack. So I spent the first year at Nirvana working on that and kind of being part of the core team and sort of overseeing some of the architecture and direction of it. And for Nirvana, our business model was really around kind of not necessarily selling the chips directly to individuals, but having companies kind of come on our cloud offering and then sort of bring their data and train their models there, which would allow us to kind of have more control over things and maybe improve things on that side. So I actually led or kickstarted the cloud effort and spent the second year doing that. Nirvana was acquired by Intel for $400 million in 2016. And then I spent 3 years at Intel, a lot of continuation on the cloud work I had done. So spending a lot of time in distributed systems and Kubernetes and building a kind of deep learning as a service type offering. So a command line interface, a web UI to sort of ease that transition for people that were starting to kind of come into the field and get interested in kind of building these models and deploying them too. So handling the inference side of that. So that kind of leads me up to last year, and some of my colleagues from Nirvana, we all had the kind of startup itch, trying to get back to our startup roots. That kind of is sort of the genesis for forming XOKind. So we just celebrated our 1-year birthday. So we're a little over a year old, so still fairly early stages. But we're trying to take our kind of machine learning know-how and apply that in the travel space, particularly focused in this case around sort of natural language processing to kind of drive some of the things we're looking to do about personalization in particular.
Awesome. Yeah, I know what you mean about the pendulum swinging, kind of going into startups and then being in bigger companies, then wanting to go back into startups. I've been through that cycle, so I totally get that. Well, that's great. And actually, this reminds me and makes me think that we probably have a whole other conversation to have in the future, which is kind of the machine learning operationalization at scale conversation. I'm spending a lot of time working on that, looking at the ecosystem around that right now. So maybe that's another future conversation. So why don't we start by, the purpose of this podcast, as you and I discussed beforehand, is really to help make all of this accessible to people who may not be familiar with all the buzzwords. We're hoping to sort of bring them in, into the crowd, into the ecosystem, and make it a lot more accessible and understandable. So why don't we start at the beginning, which is what is natural language processing? Because that's going to be sort of the focus of today's call, our meeting, and just kind of explain what it is, what it is, what it isn't, what it's comprised of, and what kind of things are involved in natural language processing. And then from there, we can kind of talk about where that lives in the stack.
Yeah, sure. Happy to do so. And yeah, this will be pretty high level, but
perfect.
Natural language processing, at least, to me, when I think of it, it's really kind of anything and everything related to computers and dealing with natural language as opposed to, say, like a structured language, like a programming language, just English text as you would speak it or write it, and really getting the computer to sort of do something intelligent around that or understand it as a sort of key basis for that. It's sort of, it's not sort of a new field. It is considered a subfield of artificial intelligence. It's been around, you can think back to like the 1950s and Turing tests, as a sort of thing that people may be aware of in terms of kind of kickstarting the field. It's also changed a lot over the years. When I was in grad school, what I was kind of studying and learning in terms of natural language processing versus what somebody would learn today, and that's only 10, 15 years difference, is drastically changed, particularly with the rise of, say, like deep learning. Most of the kind of state-of-the-art techniques are kind of leveraging these types of models today. So it's a fast-moving field. I think when people think about it, there is understanding of natural language. So a computer, if you think about sort of ingesting a document or some unstructured text, it could be in a variety of formats like speech, or it could be written down, even at a, say, pixel level. Taking that, putting some structure around it is usually sort of the first step for a natural language processing task to get some representation or semantic understanding of the sequence of characters that comprise the words in a written language of choice. And then usually what you'll do is apply that to some downstream task of interest. And so that could be things like a question answering system. It could be text summarization, right? So if you feed it a bunch of articles, you may want to kind of make sense of those or summarize those. Sentiment analysis is another type of downstream task you'll see where, is this person writing a good review, a bad review? Topic identification. Also kind of lumped in the field are things like speech recognition. So taking audio and converting that into a sort of understandable representation that the computer can then do something with. So when you hear NLP, all these things kind of encompass it.
Some of the other phrases, or I guess acronyms more accurately, that you'll hear would be things like NLU, natural language understanding, or NLG, natural language generation. Is it fair to say those are just kind of sub-elements within there?
Yeah, NLU is kind of like the first step you can think of, right? So language modeling is really the kind of first piece of that before you can then go and apply it. And there's been a lot of, certainly in the last few years, improvements in technology where you can get these sort of predictive, pre-trained models as part of like your NLU piece, and then fine tune it to go off and generate. So maybe run, natural language generation. Like GPT-3 is a good example of a generator of text, right? So this thing can kind of take in maybe a small amount of seed or starter text. It understands context and what words are following which, can kind of interpret what's being asked, and then go off and do everything from kind of generate prose, or like I said, summarization could be a sort of one outlet for that. Machine translation is another area I didn't mention, but taking an input language and say English and converting that to French or some other is another typical task.
Right.
So NLG is maybe more of a sort of downstream task, whereas NLU is the sort of initial base piece.
I had another question, but let's jump to GPT-3 since you mentioned it. I have talked about that on prior episodes with folks. So what is GPT-3 from your perspective, since you're so closely aligned in the industry? Kind of what's your summary of what it is, what they accomplished, and ultimately what does it mean?
Yeah, so GPT-3 is the sort of third in the sequence of this pre-trained generative models for NLP. It comes out of OpenAI, this company that was originally formed, I want to say around 2015 timeframe. Reid Hoffman, Elon Musk, Sam Altman kind of initially led it. It was originally kind of started as this not-for-profit to sort of democratize and sort of make available to the public AI. They're really kind of trying to tackle the AGI problem, or artificial general intelligence. So having a kind of single model to rule them all, if you will. They've been working and having some good progress in that domain. So this particular model does come out of that group. And like I said, it's the third in the sequence. They released GPT-2. I think they maybe had a few missteps in terms of how they've kind of released things and just the company's direction as a whole. So I mentioned it started as a not-for-profit, but it's now become a for-profit, a capped for-profit enterprise, which has been kind of interesting. And GPT-2, unlike a lot of the other kind of heavyweights in the industry, they have kind of open sourced their models and made them available to researchers as well as people in industry that want to take them and kind of apply them. GPT-2, they said, it was a little too powerful and they were worried about it.
GPT-3.
GPT-2 even, they did not release.
Oh, okay. I didn't realize that.
Yeah, which is a much smaller model.
Yeah.
Because they thought it could be used for sort of bad purposes. And they got a lot of kind of pushback and flack for that, because for GPT-3, which they released in, I think, May of this year, which is this massive, massive model. So 175 billion with a B parameters, this super massive neural network. They have made this available as an API. So you can, pay a price and use this model or get access to this model, which is kind of
it's a software as a service. It's a web service, to be more clear. It's what you can call. You can send it something and have it send something back.
That's right. Yeah. So they've defined a fairly simple API, and it's pretty powerful. I've played around with it. You can do quite a bit with it, but just their kind of business model and how they do get a lot of pushback, at least amongst the academic community, and that they've sort of,
I'm sure,
switched from being a not-for-profit to now this. They've capped returns for their investors at 100x or 1,000x or something like that. But they have not made the model itself available, as opposed to some other kind of prominent NLP models that are actively being used today.
Just size-wise, wouldn't they have to say, sure, you can have a copy, but you'll need to drive your data center over here and get a copy of it? I mean, isn't it just storage-wise, isn't it just ridiculously large? Or was that just the training component and the actual consolidated model wouldn't be that ridiculous?
Yeah. So the last piece is Microsoft has actually purchased exclusive writes to the source code for GPT-3.
Yeah.
The model parameters, right? 175 billion is no small feat. So we're talking, tens to hundreds of gigabytes, if not terabytes.
Right.
So just storing that on disk is one piece. But once you have that, serving that up, you don't necessarily need a lot of data, right? So this is a pre-trained model, and the sort of main kind of algorithmic sort of insight or improvement in that model is around kind of treating this as a few shot learning task. So with these large models, these pre-trained neural nets, they're basically general purpose, and they've been trained on like huge swaths of data. But what you can do is take that model and just fine tune it for your particular task. And with GPT-3, you can kind of fine tune it on the fly with a couple of examples. So the input to the API for GPT-3 is nothing more than just like a small snippet or blob of text describing the problem you want it to tackle, as well as a couple of maybe textual examples. So you can think of that, that's like, a couple kilobytes of data. And it can kind of go off and now start producing or generating outputs that are sensible based on those sort of couple of examples.
So for somebody who's never heard of this, which you're probably living under a rock, but if they really don't know anything about GPT-3 and they haven't been in the echo chamber, what can it do? Like to the regular person on the street, lay person who doesn't know much about AI, what can that thing do today that maybe wasn't possible a year ago or before the release?
Yeah, I think you're seeing it hyped up a lot because of some of the things people have shown. So if you kind of search Twitter, you'll see some really interesting examples. So in terms of like writing code in a programming language, we played around with it. Our industry or area of focus is in the travel space. So we put together a simple example wherein you can describe, recommend hotels to me that are kind of close to the beach and are in this location. And the examples we gave were like TripAdvisor links to specific hotel recommendations.
Okay.
And so it went off and generated realistic looking TripAdvisor links, right? The URL base looks great, but the actual target doesn't exist. So that's one of the other knocks against it, right?
Of course.
It's purely kind of fabricating or synthesizing or simulating this output. But it will also give a kind of concise summary of sorry, I take that back. We didn't just provide, recommend this. We said, here's a paragraph of text, summarize it and recommend some particular properties for me. So it did a good job of summarizing it. Like it'll speak, very fluently and a lot of, I'd say about 95% of what it says is actually pretty great. Like that's kind of like the step function that I think has really kind of captured people's attention over some prior models, even from the last couple of years. And just the field as a whole, how much it's improved or some of the capabilities in these models has just been, a really massive increase just in the last 5 years.
So you could give it, you essentially gave it a direction, which was provide me back a review, a summarized review. You gave it examples, which were maybe large blocks of text, and then said, summarize these and give me some nice, concise, summarized recommendations that look like these links from TripAdvisor, and it was able to do that for the most part.
Yeah, so it definitely invented something that if you just kind of skim the page and glance through, it looks perfect, right? It looks like human generated. But if you actually click on the link, that's where things can fall down, right?
Of course, because that link doesn't exist.
Yeah.
But yeah, and I've heard blog posts and news articles and poetry and all sorts of things that it's been generating.
Yeah, I've seen like the kind of explain it like I'm a 5-year-old, right? So you can kind of just, again, the input to that is you just typing your instructions that you want this, model to do, and just tacking on, and explain it to me like I'm a 5-year-old. So I think they put in an example of like, what is quantum mechanics? And it actually does a pretty coherent job of, using very simple language, right? So it's kind of got and captured or understood that piece of the ask.
Crazy. Okay, well, I think that sets the tone for the rest of the sort of the conversation we want to have. What was the, I think sort of keying off of that, in your opinion, given that let me backtrack, because you said something really interesting that I wanted to go to, and then we'll come back to this question about use cases. But you had said to me that you think natural language processing, NLP, is kind of having its ImageNet moment. A lot of people won't know what that means. So could you kind of explain, very briefly, what does that even mean? What is ImageNet and what is the meaning of that? And then secondarily, why NLP is going through that phase right now? What does that mean?
Yeah. So ImageNet was both a data set, about a 1 million records scraped from Flickr, came out of Stanford around 2010-ish timeframe. And then every year there was also a competition, computer vision focused competition around image classification and a few other kind of vision related tasks, in which sort of the probably most famous one being a classification task, right? So in this set of 1 million or 1.2 million images, they're labeled as what's the sort of main object of interest there.
Mm-hmm.
And the data set was kind of novel at the time in terms of its size and scale. So there was 10,000 different classes. So you can think about things like even like different breeds of dogs. And so the task was to, put together some computer software that would take as input one of these images and return one of these, 10,000 classes. And
a class, again, just to simplify this, could be dog, and the subclass could be whatever, German Shepherd, something like that.
Yeah, the actual label would be the sort of more specific task. So like a German Shepherd would be the label that you're looking to kind of produce. And there's 10,000 of those. And it really ran the gamut, right? So they scraped Flickr. So there could be images of cars of different types, people, or various parts of the, just natural scenes. And people had made, computer vision is another kind of like long storied field. It's had a lot of progress over the years. The approaches people were typically taking that were state of the art around 2012-ish timeframe. People were using kind of like these SIFT-based features and maybe more classical machine learning techniques. So kind of like edge detectors and using a lot of that to try and kind of understand or make sense of the scene and then try and figure out an appropriate label for that. But in 2012, kind of came out of my alma mater, University of Toronto. There was a team, Jeff Hinton and Ilya Sutskever and Alex Krzyzewski, that put together a deep neural network, ConvNet, convolutional neural network called AlexNet, that sort of just completely blew the previous state of the art from last year's competition winner, beat them by about 10% on an absolute basis, or maybe like 30% relative. So people were just shocked, right? So people that are working in this space for years and years. And at that time, vision was at a state where like a 0.5% or 1% kind of gain would be considered pretty good.
So they got a 20x improvement relative to what's happening year to year.
Yeah, like classification systems.
0.5% to 10%. So
yeah, at that time we're getting, I think maybe on the order of something like 60% top 5 misclassification rate, right? So if you can submit, say, 5 guesses for an image, is the right answer in there, maybe about 60% of the time. And with their model, I think they got down to an error rate of 15%, so about an 85% top 5 accuracy. And then that really kind of blew the doors wide open about what people thought could be possible with these deep neural networks. And this, I think the kind of key algorithmic insight was using convolutional neural networks. So a convolutional neural network kind of has this sliding window of view. Kind of you scan that over the pixels and kind of develop features over that. And that becomes the sort of layer in your neural network.
And so that was all in the image processing, computer vision kind of field. Now that was 2012. And so what you've said is NLP is kind of having its heyday now, and it's going through this big peak. So what's happening?
Yeah, so the parallel there, right? So these ConvNets kind of came in, going from small, simple edge detectors and kind of like one layer of the network to kind of understanding this hierarchy of features, because you have multiple layers of these ConvNets that slide through. So what it's doing is kind of like resizing and manipulating the image in a way that now it can kind of build up to the point where the higher level detectors are things like the circle of a wheel or these components, right? So this kind of hierarchical structure of learning, which allows it to kind of infer things much better. So the kind of parallel you'll see, and it was really around like 2018-ish. So NLP, I guess there was sort of one big advancement in terms of like representation in I think it was around 2013. You'll hear like word to vec or glove. So this is in the representation, and it was basically using a word vector or an embedding to represent the words of a given language. Prior to that, people were using things like POS tagging or like in order to feed it into a computer to recognize a sequence of words, you need to kind of represent that in some manner, right? So people can use everything from like a one hot encoding. So if your entire vocabulary is the English language vocabulary, you've got 20,000 words. Each word in that sequence could be represented as a 20,000 element vector, right? With a 1 in the place for that particular word and zeros everywhere else, which is super sparse and really inefficient. But that allows you to kind of maybe train a neural network on top of that, right? So if your sequences are input that way. And you can think of that, a large sequence of words is just an array of those.
Right.
What happened with Word2Vec is instead of that kind of representation, it sort of looks at each word in isolation, right, without any other surrounding context. But if I just give you the word bank, you can't tell if I'm talking about a physical bank where I would deposit money or the bank of a river, right? So that context is really key. And so with Word2Vec, it's a numeric vector representation that tries to encode that sort of level of semantics or meaning. So if you think about, again, each word will be represented by a vector. It's this set of numeric values, but you can kind of visualize that or sort of map that into a high dimensional space as a point.
Okay, and how would you simplify this down? I think some folks listening to this will say, he completely lost me at vectors, and now I'm really lost.
So simplify it to like 2D, right? So you can imagine kind of an X and Y axis, right?
Sure.
You can put every word as a point in that space.
Okay.
And what you want to do is kind of cluster or put together in that space words that have similar meaning.
Okay.
And then what that allows you to do is kind of do, vector operations. So you can do subtraction and then figure out, king is to man as queen is to woman would be the answer there. And so you could take the words king and queen and where they are represented in space and actually just kind of subtract them and sort of get that as a kind of candidate answer as a word. So that's what I mean.
It's a clustering, essentially.
Well, it's the representation, right? It's really just the sort of how these are represented. So instead of using the sparse one-hot encoding, we're basically embedding a little bit more semantic meaning into that representation. So that's the kind of key thing. So maybe ignoring kind of how it looks visually or how it's represented, but that was a pretty key insight in terms of improving the representation and therefore building kind of more predictive models because it embeds more information.
And so all of that essentially led to what? I mean, what did that provide to the developers or to the folks building these models or building these applications?
Yeah, so that's still kind of leading up to what I think is the sort of key moment. That's sort of the first layer, if you will, of the neural network, using that representation. The subsequent layers, or like the big improvement in 2018, was pre-training in kind of like unsupervised manner. So to train a neural network to understand language, right, you would typically give it a bunch of input examples and then they're labeled in some fashion, right? So it has some supervision or a target to go and kind of, tune its weights to. In 2018-ish timeframe, you'll hear a lot of reference to these different kind of like Sesame Street models. So like Elmo, BERT, OMFIT.
What are those? I've heard of them. I've read about them. What's the simplest version of those? What are they?
Yeah, so those are pre-trained models that are recurrent neural nets that have used this representation and gone off in an unsupervised fashion on a huge, massive swath of data. And the sort of it's a shift from kind of building these from scratch yourself for a given task to sort of starting from one of these.
Okay, so this is for somebody who wants to build an application, rather than them having to train the neural network themselves and get all that source data. These are already trained, they're pre-baked, and then they can use them as a component in the thing that they're building.
Yeah, so prior to these, people that wanted to kind of achieve state-of-the-art in some task like question answering would build from scratch, design a neural network architecture, get all the data, label it, do what they need to do. And that was sort of the best performing models. But what they've showed with BERT and other models now, you can start from one of these. That's sort of a general purpose language model. So it's trained on, say, English. There's models for other languages. It came out of Google, so you can think about the amount of input data they have to build something like this.
Right.
And then we fine tune it for our task of interest, so question answering. So this, is a
huge head start.
Yeah,
huge head start if you're trying to build something, because now you're just fine-tuning this model. You're not building this model from scratch with all the basic horizontal functional stuff that everything it needs.
Exactly. So again, you can kind of think about it learning 90% of this hierarchical representation of English language. Right. So now you can go off and take it and apply it. So that's what's really kind of opened the doors and has been a kind of ImageNet-like moment for the NLP space. So now your people.
Sorry.
Yeah, just to kind of wrap that up. Another nice thing about this space and this field is that all this stuff has been open source. So you can get these pre-trained models.
Awesome.
Like BERT is about maybe, I think, 800 megabytes if it's, they have different sizes and like I said, different languages. All of this is available for people today to kind of pick up and use and then go and apply.
Becomes a case of standing on the shoulders of giants.
Exactly. Yeah. We can't get access to Google's data, but they've kind of done a lot of the heavy lifting for us.
That's really cool. Let's talk about use cases that are becoming possible. I think that one of the big things that I want to cover in the podcast is kind of like explaining the state of the art. So you've already done that a little bit with GPT-3, but in the broader scheme of kind of computer and human interactions, either spoken or written or whatever else, or translations of either of those, what are some of the coolest, craziest things that are possible today that probably most people, 95% of the people on the street, would just be very surprised by? That more science fiction. They'd think it was science fiction, but it's actually possible today.
Yeah. When I think about that, I don't know there's a lot of like newer applications. It's more just the level of improvement in existing applications. So for example, BERT is powering Google's search today. So you're using it on a day-in, day-out basis, whether or not you know it. In terms of ranking. So again, it's just been that good, right? It's just helping achieve state of the art in all these different downstream tasks, this one model, or fine-tuned variants of that model. So the things that you can think of today that probably weren't so great are just getting like a step function or order better. Things like smart speakers have existed before. People have certainly had challenges, kind of, especially if you have an accent or speaking a foreign language. Right? Those have gotten drastically better just in the last few years as a result of that. So it may not necessarily be a new avenue or application, but it's probably gotten that much better. I think what you're starting to see on the cusp of is a lot more like chatbots and conversational agents. So the things where a human would be in a loop, you may or may not realize it, but some of that is starting to be taken over by these models because they understand enough about what you're asking. So it's no longer, if you think about like these phone systems where you can kind of like navigate your way through a menu as a baseline to, having speech and just talking to this in an automated fashion, it'll try and route your call to the appropriate, department as a second step to, the next level is now really getting in-depth understanding of what your ask is and handling that without necessarily a human getting into the loop, right?
Right.
So a good example of that, maybe again coming from Google, is like their they made kind of a splash where they built a system that could make a reservation for you at a restaurant, and it was calling the restaurant on your behalf and having a dialogue or a conversation with the person behind the counter, and it was even inserting human utterances like ums and ahs. So they had to kind of dial that piece back, but that's an area where people would probably be kind of blown away. There's some really fun demos of that, but a really powerful application of in this case, both speech to text and text to speech, right? So that sort of first phase, as well as natural language understanding and being able to interpret, the person on the other end of the phone's responses. So it was trying to figure out timing. So it's like, do you have a reservation at 6:30? Oh no, 7 isn't available. So if you think about what's involved in parsing that and handling that appropriately, it's actually really quite complex. So to have these ongoing dialogues or conversational agents they're starting to kind of appear, and I think over the next few years they'll be much more prominent.
Do you remember the old Apple Knowledge Navigator ad from probably 20 years ago? Does that ring a bell?
I do not, no.
It's this professor who's in this university. He's talking to his tablet way before they ever had the iPad. And this assistant comes up and says, you have these 3 meetings today, and your mother called last night and left a message. And it's just this very conversational back and forth with this assistant. And then he says, oh, I forgot I have to create this presentation. Can you put so-and-so on, and we'll do a video conference. We'll collaborate on building this presentation to deliver to my students. And it's all the flow is really incredible, and they were using it as this kind of long-term vision. So I always like to say, does somebody remember it? And if so, how far away is it?
Yeah.
So I'll have to send you the link after. It's a great old ad.
Yeah, there's actually been a kind of long story history there where people have been super impressed by this. So you go back to these old systems like Eliza from the 60s, or Sugarloo is another kind of big one, where people thought they were talking to a human, right? But it was just there was not a lot of like intelligence going on. It was sort of like reinterpreting a question pretty intelligently, sort of treating itself like a philosopher and sort of turning the question back on the asker, and doing some kind of smart sort of psychological tricks. But yeah, you think about stuff like that. or just how far we've come. Like I can also think about, you mentioned Apple. There's like the Simpsons parody of like the Newton and Martin writing, pick up Martin, and I was like beat up Martin.
Yeah, these things are taking a lot longer than we thought. I actually wrote an Eliza clone when I was probably 12. I wrote it in BASIC on an old Apple II Plus, and it would have this conversation with you, but it was very, old school expert system pattern recognition. It was if X, then Y. If you'd ask it a certain thing, it would just look, let's say, that's probably what you're asking me, and it would give you a standard answer back.
Yeah.
Very simple. And here we are 30 years later, right? And more than 30 years later. And we're
but a lot of that
there.
Real improvements have come just in, say, like the last 10 years.
Yeah, that's pretty cool. On that note, before we shift gears, I have a couple of podcasts that are actually, I think by the time this one gets published, they will already be out. One was with Callan Chabella. He's the CEO of Inference Solutions, and they build conversational AI systems, voice and text, for telephone companies, telcos, as well as direct for customers. And they were using them for some crazy use cases, people calling in and doing biometric like voice prints to say, hey, I'm so-and-so, I'm on the job site, this is my name, and they're remote construction or cleanup crews. They're logging in and logging out of jobs. They had all sorts of different use cases. And then the second one that was with Jim Cascade, the CEO of Conversica, and they're doing inside marketing reps and inside SDR, sales development representatives, and inside salespeople. All of those are 3 different virtual assistants that you interact with. And so when you go to their website and download a PDF, you immediately get an email from Rachel or Jim or whoever. It's, they come up with names for these agents. You start interacting with them, and they've had customers literally having conversations with these agents, these assistants, for months on end. Developing them through the pipeline, nurturing them through the process. Hey, would you like to come to this webinar? Yeah, that'd be great. Sign me up. And they'd sign it up and then send the invite. All of it is automated. It's absolutely mind-blowing.
Yeah. So, it's there, and you're starting without even knowing it to see it, right? So like article generation. So news articles is another kind of common thing. You can kind of recognize it if you kind of go off on the web. There'll be a few paragraphs that don't necessarily make sense. Most of that is because it's just fully, automatically generated.
Right. Yeah. It's bad. Yeah, exactly.
It's not quite there yet.
It's not quite there, but it's coming, and it's pretty cool to see. So I did want to just touch on kind of the stack before we get into what you're doing at XOKind. So in terms of, I always like to sort of orient people. The way I've been thinking about it, and please, correct me if you think I'm off base here, but we've kind of got all this compute infrastructure we built up over the last 20, 30 years, kind of current set of tools. We've got all this data infrastructure that we put on top, right? Everybody's been doing data warehouses and data lakes and all that for years, and getting I would say, data mature, data competent. Of course, we've always had our development environments, even though those languages shift over time. What seems to be new is we've now added kind of all these model, ML, let's say machine learning platforms and tools, model creation tools and environments on top of the development environment, which then build up to these kinds of skills that you're talking about. So vision, right? Or language, which could encompass speaker recognition and speech to text, text to speech. Search, obviously, which is kind of tied into that. As you said, the BERT model is used actually in search. So I kind of think of that as like this layer of skills, which then ultimately kind of leads up to like, what are the capabilities that this AI has? And I think that what's surprising probably to some people when you explain it is, these systems can plan, they can reason, they can predict, they can forecast, they can classify things. And that's a very useful horizontal capability. And what can you do with that? You can do all sorts of use cases like you mentioned, chatbots, virtual assistants, text analytics, machine translation, and all of those things, which then can get applied into, let's say, an industry sector like banking or finance or customer service in a tech company or whatever. So essentially kind of from compute infrastructure through data, through models, up to skills, up to capabilities, and ultimately kind of up into the use case, application of a particular use case in a sector being an application. That's kind of my murky, simplified view of the world. Would you agree with that? That's kind of how it's emerging? Or disagree?
No, I think I agree with that. I think people have different kind of areas of focus of that sort of stack.
Sure.
And I do think, I do see, if you're kind of focused in the machine learning area, the model as kind of being the key part. But to build that model, the model's not going to do anything without data, right? So
Yeah.
in particular for other types of modeling. And so we talked a lot about these kind of pre-trained models. Maybe you need less and less data for that because you're taking and adapting it. But traditionally, you've needed sort of large swaths. And there still is, building that kind of model or other types of models, generally more data wins, right? And it's not just more raw data. It's got to be like a certain quality, or maybe it's massaged in a certain way. But that
labeled correctly, or depending what you're doing.
Yeah, I mean, in NLP, that's where they've gotten a kind of another big step function or boost, is because they've been able to do it in an unsupervised fashion, right? So just the amount of data that's labeled versus the amount of data that's on the web, right? So GPT-3 was trained basically on, the entire corpus of the web. Billions and billions of documents.
Kind of hard to get your head around.
Yeah, so that's why they needed dedicated sections of Microsoft Azure, and why it costs, I think, they were like $10 million to train, or some ridiculous number like that. But like I see those as, and compute is obviously another big major ingredient. So I see those kind of feeding up into that, and yeah, that kind of output is application to some task of interest, right? You want to get it to do something, and what it can do is very broad, as people have shown, right? So some of the domains you talked about, there are certain in the NLP space, like just downstream tasks, a lot of which I've touched on, but from those, people are kind of inventing new and different ways to apply those or make use of those. So yeah, I think in short, I think I agree.
So, all right, well, let's move on to XOKind. You're in a startup. You're back in startup land. You've been there for about a year. To the degree that you're willing to share, what are you doing there, and kind of what was the genesis of this? Why this? Why you? Why here? Why now? Like, what is the genesis story here?
Yeah, I think myself. So I'm one of the co-founders. There's 4 co-founders: Arjun, Yinyan, and Sarah. Arjun, Yinyan, and I all work together at Nirvana, and mostly have a kind of engineering, machine learning background. And so I think we all kind of recognize and see this, NLP type moment. We're all kind of passionate travelers. So we wanted to kind of take that, and of the kind of apps or products or websites that were out there, we didn't see a lot in terms of, tailoring things to me and my interests. Travel is very personal, from trip to trip and in preferences. And we felt like it was taking a long time to plan trips. So to build a kind of complex itinerary. I want to go here. I want to do this. I'm traveling with my kids or my dog. And we felt like there's just a lot of room for improvement there. So given our sort of background and knowledge in the space, we felt there was a lot we could apply. So that's sort of how it came about. Arjun and Yinyan were kind of batting the idea around a little bit before I joined, but that was how it started. We kicked it off last fall. We've grown now to about 10 people. We were focused on the mobile space. So we're looking to put together an app. We originally started kind of targeting the business or leisure type traveler, sort of a younger, maybe they're working for a company and we'd be sort of sent off to XYZ location and maybe tack on a few days and spend the weekend in a new spot, right? So we started down the path of putting different pieces in place to support planning and booking travel and building such an itinerary. But around the time we got to our first MVP in the spring, COVID hit, and sort of the bottom fell out of the sort of business travel market.
Yeah, for sure. The all travel market. Yeah.
All travel, yes, but particularly business. So we kind of use that time. We do think travel, it's a big space, it's a broad space, and we think we can do a lot in that space to improve it. We started kind of pivoting within travel to look at more leisure trips, people taking road trips, looking at kind of COVID safe activities like hikes and other outdoor type activities. And so we've kind of spent the summer doing a bunch of user testing, getting feedback, and we feel pretty strong about what we've put together. And now we're in the sort of implementation phase of our beta app. So we're in, I would say, alpha beta-ish quality stage. We're still kind of adding different integrations and looking to get even smarter in terms of the types of recommendations we can make for people and really tailor them to that individual. But the plan is to kind of, keep developing on that roadmap through the spring and do a kind of full-blown public launch, kind of early next year timeframe. So like, what are we looking for today? We do have, if people do want early access to it and are willing to help give us some feedback, we'd love to hear it. So they can sign up for that on our website.
Okay, great.
We're also hiring, so particularly like on the back end and front end.
Mm-hmm.
right now. So if people have the skills, again, we have kind of postings on our website. So that's something we're looking for.
Okay.
So
I'll
if you're
grab those
interested in
links
this
from you at the
space,
end, and we can put those in the show notes, and people can click straight through to there.
yeah, that'd be great.
And so what would be, just at again at a very high level, what would be the comparison? Because I was just putting together a sort of a similar itinerary for a personal trip as well. So I've kind of have a bit of an idea, but you're right. It's kind of the traditional aggregator, travel aggregator of I'm going to go to kayak.com, or I'm going to go to, Google Flights or Google Travel or something like that. Most of it is just like, here's a massive database, narrow down your flights or whatever. And then you have to go to another site to look at the parks. And you have to go to another site to find, hikes, like go to All Trails or something and look up hikes in the area. And it's this patchwork quilt of pulling data from all over the place just to try to figure out where you want to go. So is it to help kind of solve that problem?
Yeah, so the all-in-one place aspect is pretty key to what we do. So certain sites are great for particular aspects, right? Like Airbnb is fantastic as a vacation rental provider, but you're not necessarily just going to, stay in your Airbnb. You want to link that to, here's this museum I want to go to.
Yeah.
Or, here's this hike I want to do. So our coverage is a bit more broad, and we're looking to kind of have this all-in-one place where you can just define and sort of add stops to your trip and manage it and move stuff around. We're also looking at sort of features around collaboration, right? So travel is rarely done, you solo. It may be, these days probably more likely with your immediate family.
Mm-hmm.
But if you're traveling, say, with another pod, there's a lot of coordination that tends to happen around that. Right? So say two families trying to plan a ski trip, and that could happen over text, or it could happen, some of the sort of super planners, if you will, may have a spreadsheet and dates and times. But again, we're trying to take some of that and build it in a sort of slick, easy to digest, simple to use, easy to get going, so that you can spend more time, actually doing the thing as opposed to planning the thing.
And is I'm assuming that based on our prior conversations that, NLP forms a kind of a core underlying element in this. Is that on the back end? Is it used to understand a bunch of these other sites and this other information, or is it on the front end interacting with customer, or potentially both?
Yeah, potentially both. It's certainly on the back end. So one of the pieces, and we've done sort of a proof of concept actually in the hike space. So taking that data, you can, now describe in a pretty long and elaborate fashion. Like, I'm looking for a hike that's not too long, maybe, max 5 miles, that has shade and is good for strollers, and, blah, 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 blah. And we can go off and really kind of find that with decent success, and we're getting better all the time. So that's kind of one area where we sort of POC'd that on the back end, and that's exposed in the app itself. So today it's a search interface. So you type in text box, as much as you want to do, but we're also exploring other modalities. Like, again, being focused mobile first, we're looking at things like a voice-based input as a way to kind of more naturally just tell the app what you're looking for, right?
Sure.
As opposed to a lot of traditional travel apps, you may have this explosion of filters and drop downs, and 90% of them are not really relevant to what you're looking for. So we think the kind of fast could be just tell us what you want.
Okay, well, here's one for you to fix. Did you know that there is absolutely no filter on Airbnb for do they have a king bed?
I did not know that.
So if you could get that part fixed, that would be great. That would solve a lot of problems.
Yep. Another one is like electric vehicles. Cool. So we can get at that kind of information, because we're not just say, how these are traditionally structured. Maybe there's an API, and maybe they have some fields and they're formatted a certain way, but we can also look at things like reviews and what others have said, and, weight and prioritize them. And that is where a lot of like the kind of nugget information are held today and are hard to locate.
Yes. So much of the content about the keep using that, the Airbnb, location is in the comments. You look at the most recent, or you look at the trajectory of the comments, almost the sentiment analysis as a human reading these things of, it was bad, but now it's really great. And, obviously they've upgraded the facility and they're taking better care of it. So there's so much information in those comments that if your system can understand it, that's really cool.
Yeah, where we've seen that really be helpful is in terms of like COVID, right? So if you think about restaurants, outdoor seating, is it safe? Right. Is it not? So even if you look at reviews, maybe reviews from 2 years ago are no longer relevant. Right. So there's, again, having the context and sort of being smart about how we parse that, serve it up, and make it available. are the types of things that we're looking to kind of differentiate and provide something that's unique.
That's really cool. Okay, well, we'll put show in the show notes at the bottom. We'll put the link to the company and maybe a separate link for the careers or jobs page. If you guys have something like that listed, that would be great.
Sure.
So I think let me try and summarize kind of what we talked about. And before we do that, I just want to ask you on your thoughts on recommendations for either good resources if people want to learn more about where things are at, the trajectory of the space, and kind of this this point in its development. Or secondarily and related to that, what people should be doing or working on if they're looking to work in the space, what skills they should be focusing on, things like that.
Yeah, resources, there's a ton. The web is kind of the be all and end all, and it's really democratized, access to information. So there's a ton out there. The field does move quickly. Mm-hmm. So good resources. I'm coming in more from, say, like a practitioner standpoint. Sure. So from that side, there's certainly conferences, and archive.org is where you'll see, papers published first on latest techniques, and mm-hmm. People are pretty quick about picking those up. And there's also kind of a move in the space to have sort of code along with your kind of conference submissions. So there's mm-hmm. more of immediately available and stuff you can kind of take and play around with. So good for NLP kind of writ large. There's a guy, Sebastian Reuter, who puts together a mailing list, and that's a good sort of monthly kind of capture of where, maybe it's got a bit more of an academic bent to it, but in terms of like, here's this result, it was, state of the art in this task. So if you want to kind of be on the bleeding edge, that's a good way to kind of get access to that information. He also has a site, I think it's called nlpprogress.com. Okay. So if you just want a reference of like, what's state of the art in sentiment analysis, they'll just list and with like links to the papers to kind of go off and find that.
Oh, that's cool. Okay, that's great. Well that's exactly the kind of thing that I was looking for. And we can put those links in the bottom as well. Yeah.
So if you want to stay on the bleeding edge, in terms of just getting started, like there's tons of resources. As I mentioned, a lot of these companies they're doing a lot of the hard work today is around kind of supporting and serving up the model itself. So all the stuff mm-hmm. that goes into like manipulating your data, they've kind of put these things behind APIs that are easy for people to integrate with.
Right.
So like the kind of heavyweights like Google, Amazon, if you're already using these cloud providers for other resources, they do have a pretty rich set of, machine learning APIs. So you can think about like speech recognition. It's nothing more than an API call now. So you just give it your snippet of audio and you get back transcribed text. So those are mm-hmm. good starting points.
How would you weight things like certifications or skills or languages, let's say AWS or Azure or Google certifications versus, let's say, just core coding skills?
Yeah. As a practitioner, it's really the core coding skills, but I think maybe this is just because I'm cut from the same cloth, but I think being more of a generalist. So you see people that come out and they want to be data scientists. Mm-hmm. You do see a lot of people that come from a software background. That's the kind of like natural transition sure. and progression. And having a strong, computer science fundamentals basis is the right way to sort of build, especially if you're trying to kind of deploy something, at scale. Doing these little POCs and prototypes, you can get away with, doing a lot in, say, like a Jupyter notebook and Python without not having a lot of necessary like programming language background and understanding, time complexity and space complexity and all those trade-offs. But once you want to kind of put that out into the real world, really having a grasp of that helps and goes a long way. And so that's where having an understanding of how do I work with GCP or an AWS or an Azure and, put my model out there. And you'll probably need to spin up some instances to train on because, you may need multiple GPUs and mm-hmm. So that's becoming more and more necessary. And the more you know, the sort of better you're kind of set and established to kind of make an impact and I think kind of get your stuff out there more broadly. So it's huge. Yeah.
Okay. So it sounds like at the end of the day, starting kind of going back to the beginning of the conversation, it sounds like this really is kind of coming into its own in terms of NLP is really having its maybe another heyday. Where there's a lot of possibility, a lot of applications, a lot of use cases are sort of improving rapidly. There are these step function changes or orders of magnitude improvements in terms of what it can do. So maybe not necessarily new applications, but improvement in those applications. And I think a lot of this, what I would take away is that there are these building blocks, like you've said, like Bert, the whole Sesame Street character sort of set of pre-trained models where these things become building blocks, and then other people can take those building blocks or these pre-built services like Azure or Google or Amazon's services and assemble them as component pieces and then build their applications maybe more rapidly than they could before without having to go drag themselves through the muck and build all these things from scratch.
Yeah, it's never been easier to get started. I still think at a certain point, right, it only gets you so far. And you do need to kind of, go the next layer down and do that investment and kind of understanding how these models are put together. And, the fine tuning part, you can really play around with and adapt it and get out that extra performance by going that extra mile.
Okay. Excellent. Scott, I want to say thank you so much for coming on the show. I know we've been trying to get this one on the books for quite a while, months and months at this point. So thanks so much for your patience. And it's just been really great to have you. I know we'll have future conversations, probably more about the machine learning operations at scale, things like that, just operationalizing this stuff. I think that could be a separate and interesting conversation. But thanks for taking time out of the startup and just really appreciate your time today.
Yeah, thanks for having me. It was fun.
So that brings us to the end of today's Productive AI podcast with Scott Leishman. All of the links that we discussed will be in the show notes. I hope you enjoyed the episode. Please check out those show notes for the links for everything we discussed. And thank you so much for joining us. And we'll see you on the next podcast.